Hi, everyone. My name is Aaron Smith. I'm the CEO of EVA, and I'm joined as always by Nancy Bakeman. Hi, Nancy.
Hi,
And
everyone.
we're really excited today. We've got a topic called Inspiring Homebuyers and Building Owners and Builders, I'm going to throw in there, to demand and build net zero energy and zero emission homes and buildings. So we're joined today by Paul Creecher at Heart of a Home. Many of you might have seen Heart of a Home on PBS or
Heart of a building, Aaron. Sorry.
I'm sorry. Heart of a building. I'm so
Heart of
sorry.
a building. Yep.
My print on my end is it's like a 2 font.
Okay.
So I'm trying to read it quickly. But yes,
No
Heart of a Building on PBS and YouTube. You are allowed, well, we are talking today, to go visit those links, and we'll put a link in the chat section. We're going to follow with Mr. David Takahashi, and David is a complete net zero nerd. And David, just in a little time, I hope you're not offended by me saying that, but David has done an incredible journey on his own home in Colorado, and has some incredible personal stories to share with what inspired him to go net zero, to go a very healthy home, to go a very resilient home. And then finally, we have Mr. Paul Hutton from Cunningham, who's going to be talking about his Sierra Grande project, correct?
Actually pronounced Sierra Grande.
Sierra Grande, boy, and I speak Spanish too. You'd think
Nope. You're pronouncing it correctly, Aaron, but yes,
yeah,
they pronounce it Sierra Grande.
Okay, fantastic. So we'll have the Q&A section is open. You can put questions in the Q&A section. We'll offer those at the end of today's presentation to each of our guests. And with that, Paul Creecher, I'd love to turn it over to you.
Thank you so much, Aaron.
Paul, I know you're going to talk about this, but I'm really interested. What caused you to create Heart of a Building? And I've seen several of the episodes. I know you did an episode on Thrive Home Builders, which was fantastic.
Yeah.
We've talked about some other episodes on EVA builders across the country, but what inspired you?
Well, thank you, Aaron, and thank you, Nancy. So Heart of a Building came out of 25 plus years of me being involved with doing energy efficiency work. Many of you know energy raters in the audience. So I've been a longstanding HERS energy rater and doing so since 1997. And I had a company called Lightly Treading, where we worked in Colorado and Wyoming and a little bit in other states. But being an energy rating provider for a period of time, doing also energy ratings of tens of thousands of homes, not just me, but the people on our team, did over the years. I have always been deeply inspired by the people I got to work with that were doing net zero, or back in the 90s, we really didn't have net zero as a term. It was people that were like building off grid some of the time, doing passive solar design. That was some of my background in the University of Wisconsin-Madison. I studied energy analysis and policy and worked on passive solar design from some great instructors there at that time. But I loved working with those people that were at that cutting edge, that were trying to do, whether it was to be energy independent or to be good to Mother Nature or to prove that you could build a better mousetrap than what was being built elsewhere. I've always found those people deeply inspiring. So Heart of a Building came after selling Lightly Treading. I merged with PCD Engineering, who's now part of Bowman out of Ralston, Virginia, great mechanical, electrical, plumbing engineering firm I still have the pleasure of working with part-time, helping them with projects and business development. But basically, Heart of a Building came with conversations that some of you may know Brian Dunbar at the Institute for the Built Environment at Colorado State University. Brian and I have been longstanding friends. I taught a class with him back, I guess, 15 years ago now, but on green homes. But he and I were kicking around ideas, and we said, how can we reach more people to get them to want to follow down this path of net zero and high performance? And I mean, EVA is an incredible resource for it, but how else can we be a help to help get outreach, for people to learn what can be done, and that it's not so difficult to do? Because there's a lot of people who think, oh, I'm going to do that, that's going to cost 50% more and be kind of crazy to try and even do this stuff. But to help show them that things could be done better. So we came with the idea of Heart of a Building as video documentaries. That the first one I created with some of the money from the sale of my company, Lightly Treading. Now we've had 3 more that we produced with the help of sponsors that have been fantastic. And we're Now we're going to do one on Sierra Grande this summer that Paul with Cunningham Group will get to see some images of. But we felt that the stories, the why behind people doing net zero energy homes and buildings is the most compelling thing for a large audience. Like those of us who are members of EBA, we love the nerdy details of what type of insulation did you use and what's the air tightness of the building and things like that. But for the average person, they're like, oh, I want to hear why someone would go through all this stuff. So that's what we seek to do with these episodes, is share the why. We definitely get into what is happening as well, but we try and share the why behind these stories and then connect them with great people like Cunningham Group or Bowman Engineering or others to help them implement it is our goal with that. So I'll start with that, let other people introduce themselves.
Yeah. David Takahashi, let's turn it over to you and then we can dive into your story and then Paul will turn it over to you.
Okay, my story is in the year 2010, I had a home burned to the ground in a major wildfire outside of Boulder, Colorado. The background to that is that my wife's late father was the scientist who measured the concentration of carbon dioxide in the atmosphere year after year since 1957, and whose data showed that global warming was in progress and that there would be some consequences, one of which is wildfires. So house burns to the ground. We go through some arm wrestling for 2 years and end up buying a modest 1954 ranch in Boulder, Colorado. And then every year after the fire was the next biggest fire in Colorado history. And then in 2013, we had a year's rain in 3 days, major flooding. They call it flooding of biblical proportions. So I'm sitting here saying, you know what, my father-in-law was telling me that this concentration of carbon dioxide that is 400 ppm, which is like 40 cents in $1,000, was going to have these major ramifications. And I basically didn't believe him until my house burns to the ground and I have a year's rain in 3 days. So we decided to take a look at what we could do with an existing home. There are 190 million existing homes in the US. The common belief is you have to start from scratch in order to get to net zero. So one of what our motivations was to actually just show you don't need to start from scratch. You can start with a existing home and you can get quite far. We got from 190 HERS in the start to minus 50 in 4 years.
Wow.
And all along the way, we were engaging trade people. So if you take 190 million homes and you do this work, we are going to be creating a job pool that will be the envy of the world. So, so we have job creation. We also have this idea of indoor air quality. So for 6 years, I have not had a carbon monoxide reading above 0 in my home. I highly recommend taking a look at what take a look at your home, take a look at the lowest hanging fruit, and you can do this.
Yeah. So David, how did you approach it in your own home? I know we talked a little bit about that. You wanted on, you need to get the thermal envelope right. And then you needed to get indoor air quality right. And you wanted to get electrification
I
right.
kind of had three
Yeah.
pillars.
Talk
The
us
first
through-
was reduce our demand.
Right.
The
So
second was
efficiency-
conserve what energy we demanded, and third, produce that energy and use it in our home.
Yeah. So talk us through that first pillar. What actions did you take there?
Okay, so of course there's the LEDs. There is the smart thermostat. There is just watching when we're using energy.
So kind of the
Drying clothes outside if it's sunny. It just okay, well, that's the first part.
Yeah. And then as you did those efficiency things that I think a lot of people know how
And
to
then that's the insulation, the
Right.
windows, the ceiling of the ducts, I have a infrared camera.
Yeah.
And I mentioned earlier that I have this affliction. It's called OCD. It's obsessive carbon disorder. So I'm constantly looking at my doors and making sure there's no drafts. And so
Yeah.
that's that holding on. It's again, a 60-year-old home. So the windows really weren't all working. And so we looked into replacing them, and our window person was really great and allowed us to go triple pane, single hung, to replace single pane, double hung. And it was just an incredibly affordable piece of work. And now we have actual windows that operate.
Nice thought.
David, or Aaron, if I may, really quickly, I'll just say, David is a candidate for a future Heart of a Building episode. And part of why he is that what I find endearing in David is, yes, he's become an energy nerd, but he is seeking to live more in harmony with nature. And what I mean by that is, like, he's paying attention to what's happening weather-wise, what's happening with his lifestyle. And in my opinion, that's a huge part of the equation, that no matter how amazing a home or building we build, those of us in the industry know 25% of energy usage comes down to how the occupant is behaving. And it's such an important part that we're educating people that if they care, and we hope more and more people care, it's like, it's not just building a great net zero energy building. It's like thinking about what's happening in the weather around you and how you're interacting with that, and how that all is part of it, and thinking about drying clothes outside, or, so it's anyway, I just want to interject that because it's such an important part. We, the builders, the people in the industry, the engineers, we are so important, but there's a quarter of the load that comes back to the occupant saying, I care. So anyway, yeah.
Well, I love what you're saying, David, because you tightened your envelope, you tightened up your windows, you tightened your air ducts, and then I know you did a blower door test. So I assume Paul used to be an energy rater. You had an energy rater come in and you checked that structure for tightness, right?
And it was so tight, we ended up having to go with recovery ventilation. I mean, for all the right reasons. So
absolutely. So now talk to us about that second pillar, which is, now you're saying, okay, let's do ERV. And we always say very simply at EVA, build tight, ventilate right. Or I like to say, thou shalt put in an ERV. If you're not, you're wrong.
Yeah.
If you haven't put an ERV in yet, or an HRV, you're wrong. But talk to us about those next steps that you took around ERV and heat pump and some of those things.
Okay, so that was really important because one of our goals was to sever the gas line from the utility. And so when we bought the home, we knew that the forced air furnace was on its last legs. And so that was miraculous. So we had no embodied, energy, tied up in that. So the first thing we did was got rid of the forced air and replaced it with a heat pump air handler, a 2-ton low temperature rated air source heat pump. We've gone through polar vortexes and we've been fine. Minus 10 for 5 days, and we were fine.
David,
Then
you
the
chose
final,
Mitsubishi, correct? You chose a Mitsubishi unit?
Hyper Heat Mitsubishi.
Okay.
Highly recommended, especially in colder climates. And then the house, when we bought it, we were lucky. We had an electric stove. We had all electric except for the furnace and the water heater.
Mhm.
So the water heater was the final thing before we could turn off the natural gas. And that was kind of problematic, but we found we're a 1,000 square foot ranch, so we don't have a lot of space. So we wanted to put the hot water back into the water closet, and we wanted to do it with heat pumps. And so we found one that is sitting outside. The compressor is outside. The hot water reservoir is in the water closet. And the refrigerant is, of all things, carbon dioxide.
So this is a Sandon split heat pump
Sandon,
water
yes.
heater that we use.
Very good, very
Yeah.
good, Aaron.
Thank
Yeah.
you. Uses
And it's been wonderful and no problem. 45 gallon for the 2.5 of us, it's been wonderful. So we were able to get the utility to come out, rip out the meter, put a cap on the gas line, and ever since then, the Uris of Texas can happen, and we're just peachy.
Right. And your final piece, and actually one question that came up, do you at below -10 or at some number, does your electric heat kick in as your backup on that Mitsubishi unit?
Yes, it's the air handler itself has some heating coils,
Mhm.
so it's smart enough to know I don't have what it takes to pull heat out of the cold air, and the coils will come on, but they come on, they don't stay on during that time. They at startup they would come on. So what I've kind of learned, Aaron, is what I do is I have the ability to program my heat. So I started at like low, and 15 minutes later I up it, and 15 minutes later I up it, and 15 minutes. So I don't have that all of a sudden I want like 8 more degrees of heat. So I just kind of step it, and I find that those spikes get minimized.
Great.
Yeah.
So now you've electrified your entire house. You've gotten rid of your gas meter.
Beneficially
Now,
electrified. Mhm.
the third leg of your stool was your solar,
The
right?
solar and storage.
So tell us about the solar and
thing,
storage. Yeah.
yeah, the beautiful thing, my day is I burn battery storage all night. The sun comes up, the system wakes up and says, is anyone asking for any energy in the house? No. Does the battery need recharging? Okay. Once the battery is fully charged, there's no demand. Then we sell to the grid. And then at night, the sun goes down, the battery kicks in, and we go to the next morning. And we have about 5 days of storage.
And you're net zero on your meters since you've done this. What what kilowatt size solar panel did you use? And then what battery system and how many kilowatts for that?
Okay, so we have 10.8 kilowatt hours on the roof,
Nice.
and we have 32 kilowatts in storage, and it's iron, lithium, the great stuff. It was a challenge to get it into a 4-foot crawl space with zoning, which really wants 8 feet. But because it was iron, lithium, that doesn't have the runaway problem, we were able to permit into a really tight space. And they're worried about getting people out if there's a, electrocution or something.
Right.
But yeah, so 32, a bank of 32 is about 5 days, depending on, I mean, our big thing, of course, is the water, heating water.
Right.
Yeah. And we ended up, my wife was doing some deep spring cleaning, and something fell from a cabinet onto our resistive electric stove, which cracked the top. And it turns out to fix the top, a little bit more money, we could go induction. So now we're doing an induction. Oh my gosh.
Induction's incredible, right? We've done sessions on this. We had a professional chef out of San Francisco, Rochelle Boucher. Tell us about your experience with induction. It's amazing.
Oh, induction is just, it is so fast, it's scary. So, boil a kettle of water is like 2 minutes. And you really have to watch it, because it just goes and goes and goes. The beautiful thing is the hobs, they're not elements, they're hobs. Yeah. But they figure out what is on them and put the power where it is needed. So you need a cookware that a magnet will stick to the bottom, right, which is like cast iron. But other than that, oh my gosh, just the control. And the fact that you don't need a pot holder to pick up a pan anymore. And it's just
and the cooktop is not hot.
Yeah. And here's what I learned. So these people, they get parchment paper or newspaper and put it under their pan as they are frying their splattery food.
Yeah.
And the paper just picks up the splatter, put it in the recycle, and done deal.
David, I have one final question for you from us. What are you excited about next? As you look forward, what do you see coming that you go, this is the next?
I think it's automation. I think it's smart homes that adapt to not only the outside, but the inside. And knows that if this, then that. I think that's where we're going. And to do this in such a way that when the internet goes out, you're still good to go, that will be the key.
Fantastic.
Yep.
Mr. Creecher, I'll turn it back to you to introduce our next guest.
Sure.
Mr.
So
thank you so much.
Yeah.
And
So
just a reminder, Heart of a Building is looking for some sponsors that want to participate in underwriting, telling Mr. Takahashi's story. So reach out to Paul and Heart of a Building if you're in a position to do so.
Thank you so much on that, Aaron. So yeah, just heartofabuilding.com, you can get in touch with us. But yeah, David's story is one we very much who he would be in front of the camera and how that could be very compelling. Just the one person, because it's never one person that makes this happen. It's going to be a group of people that come together to make things work. The design, the insulators that are dense packing the walls with cellulose in his home are critical people in making home retrofits. So the whole team of people. So yeah, we love that. Now, Paul Hutton, who's here from Cunningham, we have the pleasure of saying we do have the sponsorship support to produce a story that he was very much involved with. But Paul has been involved in the daylighting, sustainability, passive solar design world for, it's fair to say, 4 decades, right, Paul, in that range. Doesn't look it, doesn't act it, in my opinion, but he's been doing it that long. And I've had the pleasure of working with Paul on like Denver Energy Codes committees in the past, and was really great as we talked about this story of Sierra Grande, a high school down in southern Colorado that is built towards passive house compliance standards and what they've done. And we're going to produce that this summer and get it on the air, we hope in September or October, to have that out there. But Paul, if you would be so kind to start off and tell us about Cunningham Group and you a little bit more.
Yeah, thanks so much, Paul. And David, thanks for that lovely story. Every time I hear you tell that, I learn something new. I pick up a new nuance about that. So thanks. I really loved it, especially that it's about a renovation. And so much of the challenge we face isn't about great new buildings. It's about how to renovate the enormous existing building stock. So I just want to underscore how critical that is. But I will talk about some new buildings here today. And so I am the director of regenerative design for Cunningham. Cunningham is a large US and international design firm with 6 US offices, 2 overseas offices. And we do primarily 5 sectors: healthcare, educational, multifamily living, resort, entertainment, and what am I forgetting out? Oh, of course, workplace. Yeah, so those are the 5 sectors that we're actively engaged in. And my role is to try to decarbonize and bring all of those sectors to net zero energy across the country and abroad. So it's a wonderful job in terms of every day you can imagine is different, a lot of different places to go and see. And it's really an exciting moment for me to be in. But I'm going to look back real quick. Paul mentioned 4 decades. That's right. In fact, it's a little bit more than that. And my story is that the way I put myself through graduate architecture school was to design what we called then solar houses. And it's almost comical to me to look back at the misconceptions that we had at this point. Are you seeing a screen with the house in the woods?
It's true now, yes.
I don't think I've ever showed you this, Paul. So this is a house I designed as a graduate student in 1978. And back then, the obsession was we got to stop using fossil fuel. We weren't thinking at all about where electricity came from. It just wasn't on the radar screen. And not just for me, for the whole professional design community. We're obsessed with, those of us that cared about the environment, how do we stop using fossil fuel? Mainly because, not global warming, because we're convinced we're going to run out of it. It was all about resource depletion, the limits to growth. And so that's what drove this kind of project. So this is a building that I designed and helped construct, and it has no fossil fuel use. It has passive cooling through earth tubes. It's a double thermal envelope. It has a lot of obviously south-facing passive gain. There's some other features that you can't see. And in fact, what's one thing interesting about this kind of houses, these houses were looked at by the German designers who adopted it, turned it into Passivhaus, and now Passivhaus is back here in the US. But the origins of Passivhaus are not, in fact, German. They are right here in the 70s in the United States from the designers who are doing this kind of work. And this image makes me smile for one other reason. I'll just share with you a personal story. I was pouring the concrete foundations with my good friends, the contractor, Bill and Company, and the concrete truck was late. Of course, we didn't have cell phones then. So I was late to my own wedding rehearsal because of this house. Amazingly, I'm still married to the same amazing woman, but it was a close call. So passive design puts a lot at risk. You're putting everything on the line, right, Paul? We've all learned that. So I'm going to move ahead where I live today. So 20 years ago, when things were not quite as advanced as they are now, we didn't have all these cool mini splits and things like that. So this is a house I designed on a property that's a former cattle dairy ranch. And so we took on this property with the desire to restore the ecosystems of the riparian corridor and the upland shortgrass prairie. And so that's what we have been working on, my wife and I, for the last 20 years. Of course, if you're in that kind of environment, you'd better do a house that's good enough that merits being there. And so this is a super insulated house, quad pane windows. Thank you, Alpen windows up in Longmont, all geo and the slab is doing both the heating and cooling, all radiant. So radiant cooling is still kind of a trick. Got to be very careful with it, but it can be a wonderful system here in Colorado. So the house is prepped for an ERV, David, but we haven't had to install an ERV yet. I keep, like you, monitoring indoor air quality, and it's all based on natural ventilation. So just wanted to share you quickly. I have a passion for house design too, but at Cunningham, we don't do any single family houses. We only do multifamily and what you would generally consider to be commercial. So anyway, this was a fun project, and I, like David, it's an ongoing experiment. We are always learning about how buildings like this operate, how to make them better. Our next move is an induction. Back 20 years ago, David, my wife would not hear anything about electric cooking. No way. She had to have a gas range, and that's what I still have. But I think as that unit is near the end of its life, I'm convinced, and have been planting the seeds with my wife, we're going to go induction. So get ready for it. And of course, she asks all the same questions about what about the pots and pans I have. But, okay, so now I'm going to move to some more commercial work. And especially, and Paul mentioned this, one of the mainstays throughout my career, especially in Colorado and the Rocky Mountain region, has been PK-12 school design. That was a building type that I fell into very early in my career, shortly after I moved to Denver in 1980. And I continue to find myself working on these kind of buildings. At this point, I think I've designed somewhere around 250 schools. So it's kind of fun to look back through those years and look at how the design trends have evolved. This is one I especially liked. It's a smaller building. It's the Aspen Community School in Woody Creek. And it's not quite net zero energy. It's sort of on the path to net zero energy. But it was the first building where we systematically also looked at the issue of embodied carbon. So this is a low embodied carbon building at the same time as it is a low operational carbon building. So I'm convinced that embodied carbon.
Paul, can you just explain those two ideas to the audience just really quickly?
Absolutely. So we're all familiar with the issue of operational carbon, the emissions associated with burning fossil fuel, with generating the electricity we use in our buildings. What has only gotten attention relatively recently is the fact that building materials have a substantial impact on the worldwide economy and on climate. In fact, the best numbers available are that construction materials alone are 11% of worldwide emissions, 11%. And the single biggest piece to that is concrete, followed closely by steel. In fact, this is a great statistic. I love this one. If you just took all the concrete plants in the world and put them together and called that the United States of concrete, that would, as an emitter, be the third largest country in the world. It's only behind US China in its emissions. So concrete is an enormously impactful material, but it's not alone. So what we're learning as our buildings become incredibly energy efficient in terms of operational carbon, that's a great thing, and we want to do more of it. The challenge now is the materials. So if I look at the 30-year life cycle of a new, really super energy efficient building, there will actually be more emissions related to the materials than to the fossil fuel and any other emissions related to operating it. And so that's why we're starting to get really serious about the concrete, the steel, all the materials that go into the building. So it's a really important thing that we start to think about. So anyway, that was a little bit of the story about why this building was sort of a turning point for us. It's when we began to combine those two important interests. So I was going to share with you next a story about a school in Boulder Valley. This is the Meadowlark School. It's a PK-12 school, not too far, I think, David, from where you live. And the reason I wanted to share this is a school where we really started to work on two issues simultaneously. The district, Boulder Valley Schools, challenges to make this their most energy efficient building. At the same time, they had a brand new commitment to indoor air quality and environmental conditions that benefit the ability of their students to learn and their teachers to teach. And so that was a bit of a nuance here. So the obsession here became natural ventilation as the primary mechanical strategy. All the mechanical systems in this building actually are backup to the strategy of natural ventilation. So you can see in this window that there are operable windows. In addition to those operable windows, there are through-wall vents that are operated by the students. Every classroom has a signaling system, red light, green light, very simple. Green light, if you want to be comfortable, you're going to have to open the louvers and windows in your room. If the red light's on, you better close it, or you'll sacrifice some comfort. I love that there are consequences. We want to involve the clients in how their buildings operate. So, and this in fact has turned out to be tied for the most energy efficient building in the Boulder Valley School District. But it's got absolutely fantastic indoor air quality. You know, we've been monitoring this building, and what we measure is not CO, but CO2 because of the very dense occupation level that we find in school buildings. Think about it, 30 kids in an 800 square foot room. That's very dense, denser than any other commercial building type we deal with. So that's why it's so important to pay attention to the indoor air quality. And this building has been able to deliver for the district and for us that elusive combination of air quality and energy efficiency. So now, I promised I'd get there. This is the building that Paul was mentioning, the Sierra Grand. And that's Mount Blanca right behind it. You see there in the top left. What an amazing setting right off of 160 headed west toward Pagosa Springs, where Paul is moving shortly. And it's a spectacular site to say the least. And this, though, is a rural district. It's one of those districts that has an enormous geographic area and only enough students for one building. So all the students, PK, all the way through 12, are in this one location. This is it for the whole district. And we needed to respect that this is a district with very limited resources. They can't pass a bond issue. They could only build this to begin with because they got a BEST grant from the state of Colorado. And we have done a few of these projects in the past and learned an important lesson. A lot of the technologies that architects and designers like to use to hit net zero energy fail if they don't have high quality maintenance capability on site. And a district like this, they're likely to have one or two maintenance people just to keep the building clean. They do not have anything resembling the resources that big urban school districts have to maintain this. This has to be as bomb-proof and as simple as possible to operate. So knowing that, we approached this project from the very beginning and actually pitched to the client, hey, there's this thing called Passivhaus. We think would be a great strategy with you. Of course, they had never heard of Passivhaus, being laymen. How would they know about that? And the simple way we explained it was this: look, we're going to take your budget and not spend an extra dollar, but we're going to reallocate the normal division of budget between envelope and mechanical systems. We're going to take a few dollars from mechanical systems and put them into an improved thermal envelope. And that will enable us to simplify the mechanical system, which has not one benefit, but a few. The first benefit is, well, it's cheaper to install, so we can keep the balanced budget. The second thing is it's easier to maintain. And so this is not a case of downsizing systems. I always think that rarely gets us where we need to get. We need to grossly simplify systems in these kind of buildings to stay on budget. So this is a colder climate than Denver. This is the next climate zone up from Denver. It's colder and higher altitude. And this is a case where we were able to hit our target of being net zero energy ready and invest more in the envelope and less in the mechanical system. So we eliminated perimeter heat entirely. It's very rare to see a large commercial building like this with no perimeter heat. We, in fact, got rid of the boiler. Not only is there not a gas boiler, there's not an electric boiler in this building. This is very, very simple technology. And when I look at this, I'm still amazed we pulled it off and made the budget. The insulation values in this envelope are literally twice our previous best building. And they're literally twice what almost every other commercial building in Colorado is still seeking to achieve. So just some reference values: the roof is R60, 65. The walls are R50. We're lucky in most cases to hit 25. And especially important, we have triple pane windows. Again, thank you to Colorado company Aspen. And the entire slab, not just the perimeter, the entire floor slab has sub-slab insulation. So that's the key to getting an envelope so good, the mechanical system becomes dead simple and easy to maintain. So that's the story here that I wanted to share with you. I wish I had a few years of operating data to really prove this out. We're just into the first few months of Shakedown still. This opened in January. So we hope this is a great story in the process of emerging. So Aaron, that's what I wanted to share with you all today. With that, I'll stop sharing. I can always go back to photos if we
Paul,
want.
I have so many questions, but how are you heating and cooling the structure?
Yeah.
100% electric. I mean, this, and you would normally not do this. I mean, this is VAV. So we wanted out of the box components that any mechanical maintenance person would know how to use. So it's rooftop units and VAV boxes. It's that simple.
And
But
can you expound, Paul, on what a VAV? I think people are maybe familiar with VRVs and heat pumps, but not with VAV on the residential
So
side.
VAV is variable air volume. So there's a terminal box basically for each classroom or space. And that box is tuned or adjusted. And then there is a heating element, in this case, an electric heating element that turns up or down to modulate the air temperature as it's delivered into the room. But what's interesting about a building like this, because of the density of the students generating heat and the equipment like computers generating heat, this building goes into cooling mode at about 52 degrees outside temperature. So actually it's heavier on the air conditioning side even than it is on the heating side. So that's where the balance point happens in a building like this. But I think this is the future of where our commercial buildings are going to go that are trying to head toward net zero. And as David talked about the problems of getting rid of fossil fuels, at school, I've got the problem of a food service crew. It's not just the cooktop, right? The cooktop's not hard, but they're used to things like deep fryers and other stuff. So a commercial kitchen going all electric is a much bigger challenge than the residential. But fortunately, we had a really cooperative client that was willing to listen to our pitch. And in the end, they decided, yeah, they could live with an electric kitchen. Unfortunately, I was late in the process of documents and I looked at our plans and I found some propane gas piping and asked my team, why do we still have propane gas piping in this building? They said, well, it's the science labs, of course. And I said, oh man, you got to be kidding me. We're going to do a whole system for half a dozen Bunsen burners. So I went on this massive search and I found an electric Bunsen burner out of the UK. And we had to import some of those to make this building all electric. So there you go. I'll stop.
Question on your VAVs. Are you using some free cooling during nighttime? Because you have I assume a large, right? So you're pre-cooling the building at night with free cooling from the outside with your VAV boxes and bringing that to temperature before the students.
Absolutely. Yeah, we've got that really cool nighttime air in the high San Luis Valley. I mean, this is elevation of 7,000 feet right up against Mount Blanca. So cool air at night's easy to come by.
Right. Yeah. Like, and this is why we're so privileged. We're going to get to put this into a 30-minute documentary episode and have it airing on Rocky Mountain PBS in the not too distant future. So it's like, so this story is fantastic. We want it to be spread out to larger school district areas, not just rural district areas, but to see that you invest the dollars. You touched on this, Paul, but I think I'll just reiterate that the investment dollars they put into the envelope were offset by what they saved in the mechanical equipment. So the project came out a little less expensive, is my understanding, than if you'd have built it to prescriptive code with rooftop units and the like. Is that correct, Paul?
Yeah, more or less. Yeah. I mean, we did not ask the state for a single extra dollar to implement this project.
Yeah. So it's just thinking. So anyway, it's all of your decades of experience coming to bear, I guess, bearing fruit, but it's still outstanding that you did that. And so we want to get that. We are going to get that story shared. So that'll be outstanding. So we're so happy with that. But we'll be happy to have anyone who would like to be talking about sponsorship of that episode. You can still get on board, but we do have the resources to go forward, and we can have a large camera crew with drone footage and 3 camera people and capture a lot of great video on this story and get it out there.
Mm-hmm.
Great.
We're excited for that.
Mr. Hutton, one question that came in is, how does your company, or what tools do you use to calculate embodied and operational carbon in your projects? Is there a particular calculator you like to use?
No one tool does everything that we needed to do. Tally for Embodied Carbon is probably the tool that we use the most frequently, and it's probably the workhorse for us. But we rely heavily on information from EC3. That would be the other secondary tool that's important for us. And then there are a number of other databases like Mindful Materials, Athena, and others that will occasionally pick and choose little bits from. So Tally is where it starts. In terms of operational energy, we have a couple of people in-house at Cunningham who do all of our energy modeling inside. And we do that because we want real-time response. So as soon as my designers generate a sketch, I want to be able to have a preliminary energy model the next day or two.
Right.
And so that's why we do that in-house. Now, there's kind of a challenge for us, and that is designers, everything anymore is in Autodesk Revit. And unfortunately, I don't think Revit's tools are yet good enough for us. So we have outside software packages we have to use to generate those energy models. So it's not as seamlessly integrated as you would think it would be by now, but we're getting it.
There is a new beta for EC3 Tally that allows you to export your Revit AutoCAD model into EC3 and
Yeah, that'll be cool.
get great data. So I know that's coming. I've been behind the scenes on that. Paul, another question that came in: have you utilized ground source heat pumps for any of your K through 12 projects? And how do you determine when it's cost effective to use ground source versus VAV versus air source heat pump?
Yeah, we had a period of time when that was our go-to system for our larger buildings, the ground source heat pump. Sort of right around 2008 through about 2014, 15, we did a lot of that. But right about that time, 14, 15, is when those systems started to get priced out of the market. The cost of drilling the field and some of the extra piping made it so those were, in our opinion, no longer cost competitive. So, for example, the Metal Arc school that I shared with you that went natural ventilation, that was our backup concept. We thought we were going to go with that building with GeoExchange. But if I remember, 102,000 square foot building, premium there was around $800,000. You know, I just could not justify a large scale GeoExchange system for a large building like that. So we have not done GeoExchange at the scale of a building now in half a dozen years. But there are some changes coming to geothermal GeoExchange technology that might start to change that. I'm looking at, there's a system called ATES, Aquifer Thermal Energy Transfer. That's a new approach to GeoExchange. And there's another one called Darcy. And then the third one called Gabus. And so I think it's exciting that there's some creative thinking coming back into the GeoExchange arena, and hopefully basically we can use fewer bores to get the same thermal benefits. That's really the change that has to happen, because we don't have enough drillers in Colorado available to keep the prices competitive. Well, right. We have done one GeoExchange school in the last few years. It was up at the Adams 12 district.
Yeah. Paul, follow-up question to that. Have you looked at drain water energy recovery systems at all for any of your projects? And if so, is that something that we may see show up in residential?
We have looked at it, and I think we've implemented in some of our theme park work, but I have not personally been involved in any of those. So I'm certainly aware of the technology and think it's pretty intriguing. Of course, it depends on having enough wastewater to make it worth capturing the heat out of it. And, you know, in a residential, maybe if you had a multifamily housing project where you've got a surge of hot water every evening and every morning, that's probably where we might be able to start looking at that. So I think it's exciting technology, but I don't have much experience there yet.
Great. Question for both Mr. Hutton and Mr. Takahashi. What resources are out there that discuss the cost benefit analyses of green building sustainable construction? Specifically, what numbers will the homeowner see when, or could be a building owner in your case, Mr. Hutton, when buying, operating, and selling the building? So this is, I think, kind of that total cost of ownership question, or maybe it gets to people's why, but are there tools that you're seeing that are available for homeowners?
Do you want to go first, David? I feel like I've been talking too much.
Yeah, I would really like to see this starting to appear on the MLS. I would also like to see buildings being rated in a way that is like mile per gallon on a vehicle, so that we can be comparing accurately the costs for acquiring building A versus building B.
Yeah.
Uh,
Energy ratings as a base, and then building from that. I think there's a little note that came in from Adam Stefanagle.
Yeah.
If you want to mention that, Aaron, but yeah. So
Yeah, and I think that just the note, and I don't know, David, if you'd like to mention that, I know
Sure.
that Adam is joining us on the call, and he was really critical to your project, David.
Absolutely. Adam is what was the beating heart of our project, and he's on today. So this community is lucky to have him.
Yeah, and I think one of the things that Adam mentioned is that there's a tool called Radiant Labs that will have a consumer-facing tool out in the fall. I know, just to plug EBA a little bit, but we have a course called Selling High Performance Homes that gets into total cost of ownership and how does a builder building a net zero home where the operational costs are going to be approaching zero sell against the person down the street that they have a $400, $500, $600 a month utility bill, right? So there is a kind of a resource that I think would be good for consumers and for builders, but is really designed for their model home salespeople or their real estate agents. So there are some good tools there. I think from a modeling perspective, my take would be, and David and Paul, but David, you talked very eloquently about how important Adam is. The first thing we tell builders when they come into EBA and say, I want to get better, is get an energy rater on your team. Get a building scientist on your team. It's third-party certification for you. Even if you have a renovation that you want to do, these people are critical to understanding the process, the procedures, but oftentimes, and David, we didn't ask you what rebates you may have received, but I assume you got a rebate for your solar, you got a rebate for your battery, you got a rebate for your heat pumps, and you may have gotten a 45L tax credit for some of the things that you did to bring your house better. I got a rebate for tightening my whole envelope of my home from Excel Energy. So David, do you want to address some of those things that we can all?
Yes, definitely. We took whatever rebates we could. We were a little early on the curve. So many of the rebates that are available today were not available when we did our install. But our intention was to get the door open. And once the door was open, that was going to be a thing of beauty. So yeah, we didn't, it would have been great to have the rebates, but we would have, and we did. We just went ahead and said, this has got to happen.
Yeah.
Yeah.
And just for the audience, there's some great tools on the Building America website or the Department of Energy website that break down rebates state by state. So you can see, okay, in my state, these are the following rebates that I can take advantage of.
And
Mr.
your utilities.
Yeah, and your local utility is your best resource. And Mr. Hutton, for commercial buildings, there's incredible rebates as well. It's I think it's the 128D tax credit that often gets used by commercial customers.
Yeah, we fully expect with our commercial projects that we are going to walk our client through systematically the full range of rebate credits and deductions available to them. And usually it's a complex package, and there are ways to stack incentives. In fact, you mentioned Department of Energy. I've worked with them a long time. We have an effort right now with them called Better Building Allies, where we are trying to revamp that entire web page around all the incentives available on the commercial side, because it's gotten pretty overwhelming and hard to keep track of. But usually it's the ITC investment tax credit is the first tool that we use.
Right.
And that's usually closely followed by accelerated depreciation.
Yes.
So
and one thing I might add is whether you're, depending on the state you live in, whether you're a homeowner or a commercial building owner, there's a property assessed clean energy program that can be used as well. Have either of you had experience in using that program?
I have not. I'd like to know more about it.
Okay. David?
It's not available residential in Colorado. We're really pressing for it.
Yeah.
It's wonderful, but
It is.
it's commercial right now.
Yeah, it is available in Minnesota for certain project types that extend into multifamily residential,
Yeah.
which is great. So another great comment from Adam that our friends over at BPI have a new certificate for building decarbonization specialists. I mean, I think our take from the residential side, Paul Hutton, is that our energy raters or energy assessors in Canada are going to be a critical piece for helping us understand operational and embodied carbon. So great to hear that BPI is coming out with that tool.
Yeah.
Let me see, we got a couple new questions. We talked about that one. Okay, we got the payback question, right? I mean, we've got a group that I think talked about their why. They're seeing climate change in their local, particularly in Colorado, right? And they've got this why around going to net zero. We know that that helps with air quality, but and maybe this is more for you, David, but have you looked at the payback on electricity back to the grid versus the money spent to go solar and cutting off natural gas?
Yeah, I actually have. And Colorado is a little bit unfavorable to that because we pay retail, but we sell at wholesale. And we really, I'm working on getting that a little more reasonable, because that will actually take our payback period from decades to years.
Right.
So that would be a net metering where you have a going and coming at a favorable rate is really key for giving homeowners a incentive to go with solar.
Right.
Yeah.
And but you have, I assume you have a program. I don't know if your heat pump water heater has a utility monitoring on it where they can control peak demand. But I think you're seeing this J45 interconnect on all heat pump water heaters today, which allows the utility, just like a lot of them do it with our air conditioners today, or they're doing it with our heat pumps tomorrow, but you can take advantage of some of those. Did you take advantage of any of those, David?
I would love to. Our problem is that two-way communication hasn't gotten there yet.
Right.
That was a promise that we were given that was never fulfilled.
Okay.
And that is going to be key. The price signals.
Yes.
The other thing, Aaron, is using your EV as rolling storage, for heaven's sake.
Right.
Yeah. I hate, I don't want to make this about me, but my F-150 Lightning has shipped to my house. Instead of doing batteries like David did, my truck will be the battery for my house and create a microgrid. This is the most incredible thing I think that's happened for cars to be able to help us avoid peak rates.
Absolutely.
I was at our family reunion this weekend and my cousins were there from California. I sold them a bidirectional car charger and car on the fly because they have 59-cent peak rates in California right now.
Yeah.
Jacob asked me, how did I get an F-150 EV? And my answer is that literally when Ford opened it and the clock hit 60 seconds on the countdown, I ordered my F-150. So I think there's this whole other piece too that we could bring up, which is, you know, if you really believe in this, you're electrifying your home. You're going off-grid capable. But there's this piece around electrify what you drive. And there's another piece around, I mean, David, I assume you have all electric yard equipment as well.
Absolutely.
And you're charging it all with solar. And Paul,
Absolutely.
Paul, you might have an old lawnmower for the back 40 there.
No.
Okay.
No,
Well, I do
Yeah,
have a small diesel tractor still by,
Yeah.
full disclosure, yeah, because with the 80 acres.
Yeah, you got, yeah,
with,
you're not.
equipment.
Yeah, although I've seen some tractors coming out now with electric as well. So,
right.
well, this has been just any other comment? before I
I'll
wrap
just
up?
say, what David was alluding to before, where everything is going is in smart homes, smart buildings, all of these things being integrated and helping the occupants live better with what's happening outside, but also happening on the utility rate side. So that's all what's happening. But anyway, one thing I'll plug for any builders out there that are looking for energy raters, I'll say Bowman, because they're a national firm, lots of energy raters on that staff that I'm part of in a part-time capacity. So check out bowman.com and you can find a lot of good energy raters all over the country to help you out if you don't have one yet, but so do that.
Paul Hutton, do you want to take one last stab at this last question? Bill Shadid is a great friend of EBA. I see him on a lot of our calls, but he asked about the increased R value in the thermal envelope on the school. How much attention was put into air sealing the building envelope and what methods were used?
Oh, there's no point in working on the R value if you're not paying equal attention to infiltration. So those have to go hand in hand. So I lost the fight to get the building blower door tested. I can't believe I did, but I lost that fight. So I just wrote language into our contract saying, if this building doesn't meet the performance criteria, you, the contractor, are going to pay for blower door test at your cost. And you're going to have to prove to me that you did meet the criteria. So we put a very rigid specification around air tightness on this building. And we have had other schools, though, where we have been able to do blower door tests. So in fact, that's usually where we start the hard performance envelopes, is start with the infiltration because it's generally economical. It's a very affordable upgrade. And then we try to get the R values up along with it. So really, it's not just R value, it's infiltration too.
Yeah. And Paul, I mean, residentially, a lot of us use an aero barrier product to bring us down to a really good air infiltration rate. Do you have any experience using that product on commercial?
Yeah, so you, Paul, have you seen aero barrier done on commercial projects? Do you know what that one is?
Not the trade name, no.
Okay, so it's an aerosolized air sealant that they use doors to. It's fairly new on the residential side, really in traction. So we can talk about that.
Okay, yeah.
You and I offline about future projects.
More about it. Mhm.
Great. Well, I would love to wrap things up. I want to thank Paul Creecher, number one, and Heart of a Building. And Paul, I hope that you'll share the episodes upcoming with the EBA audience so we can all tune in and get a chance to see those. I hope you'll check out the existing. They're just incredible. David Takahashi, you're an inspiration to all of us. All of us can take steps today on our own homes. You're my new idol now, and I am following in your footsteps for what I'm doing with my 1962 Cape Cod. And Paul Hutton, we learn, I always say, commercial industry is 15 years ahead of residential. There's so many great things that we can learn from what's happening commercially because they're coming down the pike for us residentially. So I want to thank you so much for sharing your learnings. And Paul Creecher, I'll turn it back to you for a wrap up.
Sure. So everybody, well, this was a privilege. EBA is an organization I've loved for decades. So happy to be a part of this. Paul, David, thank you for sharing your stories. Paul, so looking forward to doing this recording of the Sierra Grand story. And David, we are going to find the sponsors so we can get your story out there and get it shared more widely so you can inspire more people and have a chance to hear you today. So again, if you want to learn more about Heart of a Building, please go to heartofabuilding.com. You can get in touch with me or others on our staff and happily talk with you about what we're up to and helping get sponsorship in. And maybe we get to come back to EBA after we've done David's story and air the video or something. We'll see. Something like that, but we'll figure that out.
Nancy, any closing thoughts?
No, great session. Really learned a lot. Thanks to all of you.
Every time we do these, it costs Nancy and I money because we're like, we got to do that to our houses now. My wife just wants a new kitchen, but she gets science technology in our house. but it's fun. All right. Thank you so much, everyone.
Thanks all.
All right. Have a good